All right, Algebra Prep, we are back with topic 2 on our new unit 4. Topic 2, we are going to talk about solving for y. So this unit is about linear problems, right? So we started with the coordinate grid to make sure we know where everything's oriented. Next week, we're going to be doing some slope from points. We're going to be looking at some graphs, lots of stuff coming. But for this week, the two topics we decided to focus on is the first one, the coordinate grid, making sure we understand it. And then today we're talking about solving for x, or solving for y. Solving for y is super important. This is part of the reason we kept making you do checks on your solving equations last unit, because we spend a lot of time often where we have equations, and if we can plug in values for x and find values for y, then we can find points on our graph, right? So let's just look at an example. So here I'm going to put number 1. Here's an example. So if I give you the problem, y equals 2x plus 3. So this is called a linear equation. We have an x value and a y value. Last unit, we were doing all one variables, right, and solving for those variables. This unit, we're going to have two variables in our problems. Usually, it's going to be an x and a y, right? So what we're talking about today is if we take this value of x here, right? If we're given a value for x, we can solve for y, right? So if, right off here on the side, right? If given a value for x, we can solve for y. What we're looking for is that ordered pair. If you remember from topic 1 notes, we talked about the ordered pair. Right, the ordered pair is where we have the x and the y values for a point on the graph, right? So when we do this, we always plug in for x because the x coordinate, right? So I'm going to write this here. The x coordinate is the independent value. Independent value. We always say that the x values are the independent, right? Independent means we get to choose, right? They're our free spirits, right? We're independent. It means nothing's tying us down. So the x coordinate, x's are independent. The y coordinate then we call dependent because the y coordinate is dependent on what we choose for x. So the y coordinate is dependent, have to sound it out, on what is chosen for the x value. So for what is chosen for x. So the x coordinate is the independent value. The y coordinate is dependent on what is chosen for x. All right, so we could pick in theory, we get to pick any values for x. In a couple weeks, we're going to talk about when we start graphing and doing t-charts, the best values to pick for x for graphing purposes. But we can pick any values we want to for x and then find the corresponding value for y. So let's go back up here to this problem, right? So here's my problem, y equals 2x plus 3. So I'm going to do a little subset A here. And I'm going to tell you I want x to equal 4. All right, so I'm going to tell you x is going to equal 4. So we're going to take this equation, y equals 2x plus 3, and instead of x in the middle, we're going to put 4. So I have y equals 2, and then I'll change that back to this red, times 4, because instead of x, we're putting 4, plus 3. All right, we're plugging in 4 for x and solving for y. Right, order of op says we do the multiply first, so 2 times 4 is 8 plus 3, so we have y equals 8 plus 3, and then we have y equals 11. And so your answer is written as an ordered pair. X is 4, y is 11, right? That's what we're looking for. We're looking for the ordered pair. When x is 4, what is y? So x is 4, y is 11. That's the ordered pair. All right, let's try another one. I'm going to do a B, subset B here. So for the same problem, same number 1 problem, now let's change and make x -3. So x equals -3 this time. So we're going to do the same equation. We have y equals 2, and then we're going to do times the -3 instead of x plus 3. Right, so instead of x, we put in -3. So 2 times -3 is -6. So y equals -6 plus 3. -6 plus 3 is -3. Again, you may use your calculator to help you with these. So y equals -3. So my ordered pair is x is -3, y is -3. They happen to be the same values. So the x coordinate's -3, the y coordinate's -3. Make sure you're putting parentheses around this ordered pair. The parentheses are what tell it's a point, right? This is a point on the graph. Y equals 2x plus 3 makes a graph. All right, let's do one more value of x for this equation. So for C, let's do x equals 0. So I have y equals 2 times 0 plus 3. Right? All right, plugging in 0 for x. So 2 times 0 is 0. Right? So y equals 0 plus 3. 0 plus 3 is 3. Y equals 3. So this point, x is 0, y is 3, is on the graph. All right, so that's what we're doing today. So we're going to do 2 more problems together to make sure we understand this. All right, so if you need to pause and finish this up, finish it up, and I'm going to go on to number 2. All right, so number 2 here, I have y equals -4x plus 9. So there's my linear equation. Y equals -4x minus, oh, I wrote the wrong problem down. Let's try it again. Doop, doop, doop. Minus 9. I wanted to write minus 9. Sorry about that. Y equals -4x minus 9 is the problem I want to do here. Right? So we're going to take out this x here, and we're going to be putting in values for x. So let's take a look at some possible choices here. So let's do A. This time I'm going to say x equals 1. Right, so we're going to make x 1 and solve for y. So we're trying to find the point on the graph where x is 1. So I have y equals -4 times 1 minus 9. Right, order of op, we do this part first. So I have -4 minus 9. So I have y equals -4 minus 9, because -4 times 1 is -4. And then I need to do this. So it's -4. If you were doing keep, change, switch, right, we could keep, change, switch this. We'd keep the -4. We'd change that to addition. We switch that to -9. Right, -4 plus -9 is -13. So y equals -13. So the point on the graph is 1, comma, -13. When x is 1, y is -13. All right, let's do B. Let's do x is -3 this time. Right, so I have y equals -4 times -3. I like to use the parentheses for this times, especially with negative numbers, so we don't accidentally think it's subtraction, minus 9. There's a lot of negative signs there, so we need to be careful. So let's do the multiply first, right, because we always multiply before we add or subtract. So -4 times -3 is positive 12. Right, so y equals 12 minus 9. And then 12 minus 9 is 3. Y equals 3. So when x is -3, y is 3. Right? So if we were on a graph, right, we're gonna sketch this. When x is 1, 2, -3, y is 1, 2, 3. So -3, 3, would plot right here, right? If we were going to sketch it, just to remind you that this is what we're doing. These are our x's, those are our y's. All right, let's do one more on this problem here. So let's do, I'm going to do C right here down, kind of down here by my graph. Let's do x equals 1/2. Whoa, let's make x a fraction, right? X can be a whole number, x can be a fraction, x can be a decimal, x can be anything we want it to be. So I have y equals -4 times 1/2 minus 9. So here we go. I'm going to rewrite this problem with my -4 over 1 times 1/2 minus 9, right? To make that fraction, a whole number times a fraction might be a little bit easier, because then I have y equals -4 divided by 2 minus 9, because -4 times 1 is -4, 1 times 2 is 2. Now I can do the division, right? We do dividing before we subtract. So y equals -2 minus 9. And then we do this, -2 plus -9 is -11. So we have y equals -11. So when x is 1/2, y is -11. So that's the point, 1/2, comma, -11 in parentheses. All right, so we found 3 different values of x, plugged them in, and found values of y. All 3 of these points, 1, comma, -13, -3, comma, 3, 1/2, comma, -11 are going to fall on the exact same graph of a line. We will be doing more with those lines and graphs next week. All right, one more. Let's do one last problem here, and then you have lots of problems to practice on for your homework. Come on, page 3. There we go. There we go. Number 3. All right, last problem. Let's do y equals 1/3 x, oops, sorry, I hit that in the wrong place, x minus 6. We're going to be dealing with lots of fractions in this unit. So when we see the fraction, let's not shut down and freak out. The fraction is actually going to be very helpful to us. So this is a very common linear equation, y equals 1/3 x minus 6, right? And so here we go. We're going to plug in values for x. So let's start by using x equals 9. So for a, let's do x equals 9. So when we go to write this equation, y equals 1/3 times 9. I'm going to go ahead and put that 9 as a fraction, right? 9 over 1 to make that math a little bit easier. Minus 6. So so multiply across the top. 9 times 1 is 9. 3 times 1 is 3 on the bottom, right? So I have y equals 9 divided by 3 minus 6. Do the division next. 9 divided by 3 is 3. So we have y equals 3 minus 6. And then 3 minus 6 is 3 plus a -6, which is -3. You can also put 3 minus 6 straight into your calculator and get that as well. All right, so we have y equals -3. So the point we're looking at is 9, comma, -3. When x is 9, y is -3. All right, let's try 2 more values for x here. So b, I have x equals -12. So let's do x equals -12. So what is y when x is -12? So I have y equals 1/3 times -12. So I'm going to do -12 over 1, because make a fraction times a fraction, minus 6, right? Order of opposites. So let's multiply across the top, multiply across the bottom. So -12 over 3 minus 6, right? Multiply those two fractions, and then let's do the division. -12 divided by 3 is -4 minus 6. So y equals -4 minus 6. So keep the -4, change it to addition, switch it to -6. So that is -4 plus -6 is -10. So y equals -10. So my point on the graph is -12, comma, -10. There we are. There's my point on the graph. That is a parentheses in front of that negative 12. It doesn't look like it. All right, one last problem, or one last value for x. All right, what if we do x equals 2/3, right? Another fraction, uh-oh. Let's see what happens. If we remember our fraction rules, it should not be too challenging, right? So we have y equals 1/3 times 2/3 minus 6, right? So 1/3 minus 2/3 minus 6. So now we gotta get the fraction together. So 2 times 1 on top is 2, 3 times 3 is 9 on the bottom. Now that we're at this point, kind of a pain in the butt because we can't add or subtract fractions unless we have a common denominator. So we're just going to put a 1 under that 6 here, and let's make a common denominator. So we can multiply this 6 by 9 on the top and the bottom, and then that's going to give me, this 2/9 stays the same. 6 times 9 is 54. 9 times 1 is 9. Now I have y equals 2/9 minus 54/9, sorry. So 2/9 minus 54/9. Now that we have common denominators, we can subtract across the top. So 2 minus 54 is the same as 2 plus a negative 54, which is negative 52/9. So this point is actually a fraction, both the x-coordinate and the y-coordinate are fractions. The x-coordinate's 2/3, the y-coordinate is negative 52/9, right? Do not need to all be whole numbers. Every single point on the line needs to be represented. So there's fractional numbers. You can put any number you want into for x, and you will find a value for y that is on that graph. Okay, so this solving for y is what topic 2 is all about. So you have 4.02 homework on this to help you practice and make sure you understand how to solve for y.